So welcome back, and we will study about the environmental chemistry, which we got the explanation from the last video. So these questions can come like these questions in IIT and NEET. Okay, so let us start. The primary pollutant that leads to photochemical smog is, we already studied in the last video that smog is made up of smoke plus fog, and there are two types of smogs, classical and photochemical. Here we go like this. So we know classical smog, it is of cold and humid, it needs sulfur oxides, and photochemical smog needs nitrogen oxides. So the answer here will be nitrogen oxides. All right, here you go with the explanation. The primary pollutant that leads to photochemical smog is nitrogen oxides. Burning of fossil fuels such as petrol and diesel in automobiles, reaction between nitrogen and oxygen and other such reactions result in a variety of pollutants, two main of which are hydrocarbons, which are unburned fuel, and nitric oxide NO. You can see the reactions. And when the concentration of these pollutants is sufficiently high, a chain reaction initiates because of the interaction of sunlight with oxides of nitrogen, resulting in photochemical smog. Okay. Coming to our next question, the correct set of species responsible for the photochemical smog. Even in our previous video, we saw the chain reactions. Okay, nitrogen dioxide in presence of sunlight gives you nitrogen oxide plus oxygen O, right? Nitric oxide. Okay, we saw this, right? So here the answer will be option C, nitric oxide, nitrogen dioxide, ozone, and hydrocarbons. Photochemical smog appears in warm, dry, and sunny climate which are obtained by the action of sunlight on unsaturated hydrocarbons and nitrogen oxides. Following reactions are involved during the formation of photochemical smog. Okay, so you can see originates from burning of fossil fuels. Nascent oxygen is O2. Only a single O is nothing but nascent oxygen. It reacts rapidly with NO. Brown gas in high concentration forms haze. 3CH4 unburnt hydrocarbon gives you formaldehyde, acrolein, etc. Now our next question is, air pollution that occurs in sunlight is oxidizing smog or reducing smog. It is oxidizing smog. In sunlight, oxidizing smog or photochemical smog or Los Angeles smog is formed. The smog is brown in color. It occurs in warm, dry, and sunny climate. In presence of sunlight, nitrogen oxides, oxygen, and unburnt hydrocarbons of air combine to produce the photochemical smog, which mainly contains peroxyacetyl nitrate (PAN). We saw this all in our previous video. You can just go in the previous video and check it. All the explanation is given. Now, the regions of the atmosphere where clouds form and where we live, respectively, are. We know in stratosphere clouds don't form. There you have ozone, etc. We don't have clouds there. And we also live in troposphere. So option B, troposphere and troposphere. Still giving you an explanation. The lowest region of atmosphere is troposphere, which extends up to the height of 10 kilometers approximately from sea level. We live in the tropospheric region. It contains air, water vapor, and dust, which can form clouds with the help of strong air movement. Above the troposphere, stratospheric region extends up to 50 kilometers from sea level. It contains mainly nitrogen, oxygen, and ozone, and little water vapor. Ozone in the stratosphere absorbs 99.5% of the sun's harmful ultraviolet radiations and thus protects the lives on the earth. But nowadays, ozone is also having holes. Now our next question is, the layer of atmosphere between 10 kilometers to 50 kilometers above the sea level is called, of course, stratosphere. Next, excessive release of carbon dioxide into the atmosphere results in formation of smog, polar vortex, depletion of ozone, and global warming. So answer is global warming. I already explained in the previous video that carbon dioxide is good because plants prepare their food, photosynthesis. But excess of carbon dioxide will cause global warming. The next question is the maximum prescribed concentration of copper in drinking water is 5 ppm, 0.5 ppm, 0.05 ppm, or 3 ppm. ppm is nothing but parts per million, which is answer is 3 ppm. Have a look at this table. The seventh question. According to WHO, World Health Organization, and United States Environmental Protection Agency guidelines, maximum allowable concentration of metals in drinking water are as follows: cadmium, manganese, aluminium, ferrum, that is iron, copper, and zinc. Maximum concentration parts per million. You can see for manganese it is 0.05, for copper it is 3, for zinc it is 5. Our next question is assertion and a reason is given. So assertion is that ozone is destroyed by chlorofluorocarbons, CFCs, also known as freons, in the upper stratosphere, and the reason is ozone holes increase the amount of UV radiation reaching the earth. So option B, assertion and reason, both are correct, and the reason is the correct explanation for the assertion. Here you go. Eighth one, ozone is destroyed by CFCs in the upper stratosphere. These compounds ultimately reach the stratosphere, where they get broken down by the powerful UV radiations and release chlorine-free radical. So free radicals are not good. So the chlorine-free radicals react with ozone and cause its depletion by converting it into chlorine monoxide radical and molecular oxygen. Ozone holes increase the amount of UV radiations reaching the earth, causing skin cancer, sunburns, aging of skin, etc. Which is wrong with respect to our responsibility as a human being to protect our environment. Restricting the use of vehicles, yes, we need to. Avoiding the use of food-lighted facilities, yes, we should avoid. Setting up compost and in gardens, yes, we should set up. And using plastic bags, no, we should not use plastic bags. So it is option D, be careful and answer this. Here you can have some explanation. Using plastic bags is wrong with respect to responsibility as a human being to protect our environment. Plastic bags are non-biodegradable in nature. It remains in the environment as such and does not degrade by bacteria. If it is not disposed properly, then it may lead serious threat to the environment. The activities that can be used to protect our environment are as follows: restricting the use of vehicles, avoiding the use of food-lighted facilities, setting up compost bin in gardens. Just now we saw in the options. Our next question is, the upper stratosphere consisting of the ozone layer protects us from the sun's radiation that falls in the wavelength region of, you have the options here. So option B, 400 to 550 nanometers. Look at the data given. Sun emits UV radiations which, according to following EM categorization, have the wavelength range from 1 nanometer to 400 nanometers. Nanometers is nothing but 10 power minus 9 meters. So this radio waves, microwaves, infrared waves, visible rays, ultraviolet rays, X-rays, and gamma rays. Sorry, option D is correct. 200 to 315 nanometers. Option D. Okay, so our next question goes, the compound that is not a common component of photochemical smog. We know all these three components, B, C, and D, but CF2, Cl2 we didn't see, so it's option A. A quick explanation: freons or CFCs or chlorofluorocarbons, that is CF2, Cl2, is not the common component of photochemical smog. This smog is produced as a result of tropospheric pollution, which the freons are the components of stratospheric pollution. These are in fact considered as the major cause of ozone layer depletion. So the next question is, what samples with BOD values of 4 ppm and 18 ppm respectively are? So it is clean and highly polluted. Do you want to see my explanation? You can see in my previous video I have just discussed about BOD, biological oxygen demand. Biochemical oxygen demand. So the amount of oxygen required by bacteria to break down the organic matter present in a certain value of a sample of water is called biochemical oxygen demand. The amount of BOD in the water is a measure of the amount of organic material in the water in terms of how much oxygen will be required to break down biologically. Clean water would have BOD value of less than 5 ppm, whereas highly polluted water would have BOD value of 17 ppm or more. So it is clean water and polluted water. The molecule that has minimum or no role in the formation of photochemical smog is N2. So N2 molecule has minimum role in the formation of photochemical smog, while CH double bond O and ozone and nitric oxide has major role. When fossil fuels are burnt, a variety of pollutants are emitted. Two of them are hydrocarbons, unburnt, and nitric oxide. When these pollutants build up to high levels, a chain reaction occurs from their interaction with sunlight. The reactions involved in the formation of photochemical smog are follows. Ozone reacts with unburnt hydrocarbon to produce chemicals such as formaldehyde, acrolein, and pan. Okay. Taj Mahal is being slowly disfigured and discolored. This is primarily due to acid rains. Acid rain pH value is 3.5 to 5.6, which constitutes strong acids like nitric acid, sulfuric acid, H2SO3, which slowly react with marble of Taj Mahal and make it disfigured and discolored. Here, calcium carbonate marble gets dissolved in acids. This is a given reaction. The higher concentration of which gas in air can cause stiffness of flower buds? It is sulfur dioxide. Explanation: organic pigments colorants present in flower buds retain their color in the oxidized form of the pigment, as their nature is itself oxidizing in nature. When they comes in contact with the moist sulfur dioxide acid rain of higher concentration, they get decolored and stiff. Okay, so sulfur dioxide reacting with water gives H2SO4. Okay, that all you see the reactions. Due to the release of H plus ions acid, the flower gets decolored and stiff. As a result, flower eventually falls off from the plant. Question the 16th question. Peroxyacetyl nitrate (PAN), an eye irritant, is produced by photochemical smog. So molecular formula of peroxyacetyl nitrate is given. It is a secondary pollutant. It is present in photochemical smog, oxidizing or Los Angeles smog. Pan is a powerful lacrimator or tear producer, and it causes breathing troubles. Tear producer, which pollutant produces tears? Nothing but peroxyacetyl nitrate. Next question. The concentration of dissolved oxygen DO in cold water can go up to 10 ppm. So the dissolved oxygen is the oxygen dissolved in water either from atmosphere or by photosynthesis. The lower concentration of dissolved oxygen in a water sample, the more polluted is the water. The lower the concentration, the more is the polluted water. The concentration range of dissolved oxygen in cold water reaches up to 10 ppm, but that in normal water at room temperature is within 5 ppm. The reaction that is not involved in the ozone layer depletion mechanism in the stratosphere. If you see the reaction B, C, and D, they have free radicals, right? They have free radicals in the reactants, but in the option A, there is no free radical. So option A. C. Methane is not present in the stratosphere, and also it cannot diffuse or escape into the stratosphere like Freon 12, CF2Cl2, chlorofluorocarbons from the atmosphere. In the stratosphere, ozone layer depletion takes place mainly by chlorofluorocarbons like CF2Cl2, and the mechanism of ozone layer depletion can be shown as, we have this. So one free radical of chlorine can destroy or deplete 10 power 5 means 10 times 5 zeros, you'll have ozone molecules, as the first reaction is involved in the formation of photochemical smog, not in ozone layer depletion. So option A is correct. Water filled in two glasses A and B have BOD values of 10 and 20 respectively. The correct statement regarding them is B is more polluted than A. A BOD value is 10. B BOD value is 20. So we know what is BOD. So clean water or drinking water has a BOD value. Water or drinking water has a BOD value of less than 5 ppm, not greater than, it's less than 5 ppm. The pH of rainwater is approximately 5.6. So in clean air, rainwater picks up some acidic oxides like carbon dioxide, sulfur dioxide obtained from volcanic eruptions. These substances make the rain slightly acidic. It's not completely neutral, so it's slightly acidic. pH value can vary from 5.6 to 6. The condition for methemoglobinemia by drinking water is greater than 50 ppm nitrate. So according to EEC, European Environment Commission, excess of NO3 minus ion in drinking water may lead to methemoglobinemia, blue baby syndrome. Remember, it also may cause stomach cancer. And the last question for today is a water sample has ppm level concentration of the following metals: ferrum, manganese, copper, zinc. The metal that makes the water sample unsuitable for drinking is manganese. Okay. So, for drinking water, the maximum recommended levels of some metals set by European Environment Commission EEC is, you have given the metals, maximum concentration in ppm is also given. As the concentration of manganese in the given water sample is more than the recommended concentration, thus it makes water suitable for drinking. So the value is of manganese is 0.05, but here it is given 5, so it is greater, so therefore answer is manganese. So thank you. If any doubt, give the question in the comments. Thank you.